Here we're going to talk about learning amino acid 3-letter and 1-letter abbreviations. And we're going to talk about some hints and some tricks to help remember, especially the exceptions. First, right, if you're going to learn the abbreviations for the amino acids, you've got to know the names of the amino acids first, right? So you must know your names of your amino acids and their structures, right, before learning their abbreviations, right? You got to learn the names. Now, most 3-letter abbreviations use the first 3 letters of the name, but there are some exceptions, right? Most 1-letter abbreviations use the first letter of the name unless that letter has already been used by another amino acid, right? So it's figuring out these exceptions once you know the names that can be difficult. Let's start with the amino acids that have aliphatic hydrocarbon side chains, right? So we have glycine, right? Glycine, its 3-letter abbreviation is gly, and G, straightforward, right? Alanine, ala, A, right? Valine, val, V. Leucine, Lu, L. So far, no surprises. We get to isoleucine. Isoleucine is an exception. We start with the I for iso, but then LE for leucine. So we get the iso and leucine into the name. So it's ILE instead of the iso, right? So this is our first exception, but it is I. Then we have proline, which is pro, and P, right? So in the aliphatic hydrocarbon side chain group, only the isoleucine breaks our pattern. If we talk about those amino acids with hydroxyl side chains, serine, Ser, and S. No surprise there. Threonine, 3, right? And T. No surprise. Phenylalanine, right? We can use Phe, but P has already been taken. So we use the sound. Since that PH makes an F sound, phenylalanine, its 1-letter code is F, right? F, right? Tyrosine, we can use tyre, but T was taken by threonine, and so we have to use something different. So we go to the 2nd letter, Y, right? So tyrosine is Y. Now, one of the most fun, I think, is tryptophan, and it is an exception for both. Instead of spelling out the word try, right, we skip the Y and go to TRP. So tryptophan is terp, right? Terp. But we've used T already, right? We don't want to use R, and another amino acid is going to use R. And so how do we come up with a way to name this one and remember the name? Well, if you're a fan of the Big Bang Theory, you know the character Barry Kripke. And Kripke has a particular speech impediment where he can't say his R's. So he would say tryptophan as twiptophan, the R as a W. And so if you remember the Barry Kripke speech impediment, you can remember that tryptophan, twiptophan, is W. For the amino acids with acidic side chains and their amide derivatives, right, for aspartic acid or deprotonated aspartate, we can use asp, but since A is taken, we have to come up with another letter. And so randomly, they picked D. So aspartic acid, asp, is D. Similarly, glutamic acid, we can use glue. Nothing else has taken glue. But it gets to be E. So asp and glue are D and E. Now, for the asparagine, right, we go AS, except instead of going P, right, that's been used. So we go N, right, to say that that nitrogen is in there. And for glutamine, we go GLN. Okay? That makes sense. There's a pattern there. But the one-letter abbreviations make less sense. Asparagine becomes N, and glutamine becomes Q. Okay? So those seem, the N is at least in the name, but the Q is a very random choice, right? This is one we just have to remember. Now, there's another thing with aspartic and glutamic, with these acids and their amide forms. When we did amino acid analysis, that is just looking for the total content of amino acids, not their sequence, we would completely hydrolyze proteins. The problem is that would hydrolyze the amides too. So both aspartate and asparagine would come out in the same pool. And we couldn't tell what part of the aspartate started as aspartate and what part started as asparagine, right? And so there was a convention to deal with that, and that was to use ASX for the three-letter code and B for the one-letter code, for the combined pool of aspartic acid and asparagine when we couldn't differentiate. In the same way, we use GLX for the glutamic acid glutamine pool, but we use Z as the one-letter code if we need to. With the amino acids that have basic side chains, that is, side chains that can be protonated to be positively charged, right? Lysine, first three letters are fine, lyse, but L has been used for leucine, so we need another letter, so someone randomly picked K. So K is lysine. Arginine, the first three letters are available. Arg works. But A was taken by alanine, so we have to come up with another letter. And so if you say its prefix like a pirate, arg, right? If you say it like a pirate, it makes sense why someone picked R. And finally, we get to histidine, which is nice to us. It follows the pattern, right? It's his and H. For the sulfur-containing side chains, methionine follows the pattern. It's met or M. Cysteine follows the pattern, right? It's cis or C, right? The cysteine dimer is a derivative from post-translational modification, so we don't have to worry about it. But we could have to worry about, right, as we've learned more, about our selenocysteine. Right? Again, drawing it as I've got everything else drawn here. Right? Our selenocysteine. Right? In older publications, you see it as selenocysteine. If people use a 3-letter abbreviation, it's SEC for selenocysteine. And if you see it in a 1-letter abbreviation, it is U. So you should be able to draw amino acids, name them, give their proper 3-letter designation, and their proper 1-letter designations.